All right, so you're given that the ellipse has its focal points at -6, 0. Okay, so that's on the x-axis. So here are our focal points. Okay, so this is our major axis. This is our minor. Okay. These are the focal points. All right. So it says this point right here satisfies the condition that PF plus PG is equal to K. All right. So what we learned in class is that this distance right here, if we take these two and we add them up, that distance is going to be the same as the length of the major axis. So I can get this length by adding those two distances up. All right, so what this is asking you for, this is K is the length of the major axis. Because PF plus PG, okay, we know that that's equal to 2A, and 2A is the same thing as the major axes. Okay, so when I look at this, the length to that vertex is 10, and the length to this vertex is 10. So the total length for the major axis is 20. So K is 20. All right, drive the equation. So here's our, all right, derive the equation of the ellipse in the form x squared over a squared plus y squared over b squared. All right, so we're told that the focal points are on the x-axis. All right, so that is going to be our major axis. And then we're told that if I take the distance from P to F and I add the distance P to G, I get 12. Well, that turns out to be the same as the length of the major axis. This is going to be 12. So I know each half of this is going to be 6, which turns out to be my A value. All right. So the way that we did this was we said the semi-major, that's A. So I know that this special sum, PF plus PG, is 12. And I know that's the length of the major axis. So that's 12, that's 2A. Okay, each half of this is A. So the whole thing, the whole length is 2A. So A is equal to 6. Okay, so in my equation here, I got x squared over 6 squared plus y squared over b squared. So b is the Pythagorean relationship in an ellipse. So b is our semi-minor. And we use this relationship, c squared plus b squared equals a squared. Okay. C is our focal points. Okay, so C is equal to 5. We figured out that A was 6. So this is 5 squared. B squared is 11. So when I do the square root of that, I get root 11. Okay, so this is going to be root 11 squared. So then my overall equation would be x squared over 36 plus y squared over 11 equals 1. All right. 21, we want to find the value of k again. Okay, and in this one, k represents the transverse axis. Okay, in the previous one, up here, k was equal to the major axis. So our transverse axis is this right here. And so when you look at your equations for a parabola, or excuse me, a hyperbola, our transverse, our two vertices, let me correct that. This is the transverse axis right there. Okay, so if I asked you, well, what's that length? You'd say that's 4. Well, that's what k is. Okay, so this distance right here is the same as the length of the transverse axis. So that length, k, has to be 4. All right. So on 22, you're given that you have a hyperbola is on the x-axis, or the foci are on the x-axis. So here are the focus points. So this is my transverse axis. And what we learned in this one is if you take this length and you subtract that length, you get the length of the transverse axis. So in this case, the length of the transverse axis is going to be 6. So this side is 3 and that side's 3. All right, so we want to get the semi-transverse, that's A. All right, so I know my equation. A is under the x. So this is going to be 3 squared. Okay, now I'm going to get the semi-conjugate. That's the other axis. And that's B. Okay. Okay, so when I'm dealing with a hyperbola, the Pythagorean relationship we use looks like this. C squared equals A squared plus B squared. Okay, C is your focal points. So the focal points are at 5. Okay, A we just got was 3. Now we can solve this for B. So y squared over 4 squared equals 1. And this shouldn't be a plus, it should be a minus. Right? So my overall answer then is x squared over 9 minus y squared over 16 is equal to 1.